girls. Today's video is going to be on the very last section that we're going to cover in Unit 3, and this is Lesson 3.2.1, Proving Equivalencies. What that really means is that we're still going to be solving systems of equations, which is listed up here. Yesterday we solved them by graphing, deciding if we had one intersection point, one solution, parallel lines, which gives us no solution, and the same line, which gives us an infinite number of solutions. Today we're going to be solving systems of equations, but this time we're going to be doing them algebraically, and that's what they mean by proving equivalencies. The method we're going to be using today is called the elimination method. And the reason it's called the elimination method is because we want to eliminate one of our variables. We have an x, we have a y in all of our equations. We want to eliminate one of them so that we can solve for the other one that's left over. So let's quickly just go to an example right away. So in this case, we have a linear system, x plus 5y equals 9. We're going to call that equation 1. 4 minus 5y equals negative 14, and we'll call that equation 2. Now you can see we have them lined up so that the x's come first, and they're one above the other. The y's come next, and then we have our equal sign and our constant. And if you recall from earlier in the year, we call this a special form of the equation of a line, and we call that standard form of the equation of a line. And that's where we have ax plus by equals c, our constant. So in order to use elimination, we need to put our equations in standard form if they're not already in standard form. So first the x's, then the y's, the equal sign, and then our constant. Now when I look at these two equations, I notice something. I notice that the coefficient in front of my y is 5. In the second equation, the coefficient in front of my y is negative 5. So if I were to add these two together, they would equal 0. And that would eliminate the y variable for me. And that's what we want to do. So we can add these two equations together. Yes, it's fine for us to add equations together. There's nothing wrong with that, as long as we're adding the same thing on this side and the same thing on this side. So now I just add my columns. If I have 1x and I add 4 more x's, I end up with 5x. As we said before, if I have 5y and I add a negative 5y, those add to 0. So I have eliminated my y. 9 plus negative 14 is going to give us negative 5. So now all I have is 5x equals negative 5. Now I can solve for x by dividing both sides by 5. So I'm left with x equals negative 1. So now we have x equals negative 1, which is great. So we already know the x coordinate of our solution, but we don't know the y coordinate yet. But now that I know what x is, I can go back to either equation 1 or equation 2, and I can plug in the x value and solve for y. So I'm going to pick equation 1. X plus 5y equals 9. I know my x value is negative 1, so I substitute that in for x. Plus 5y equals 9. To get the 5y by itself, I have to add 1 to both sides. So I've got 5y equals 10. And to solve for y, I divide both sides by 5, which gives me y equals 2. So now I know the y coordinate of my solution. So my solution is negative 1, 2. Let's look at another case. I have two equations again. Notice my x's come first and they're lined up. My y's come second. They're also lined up. The equal sign and then my constant. Now what I notice about this is that the coefficient in front of my x in my first equation is 3 and the coefficient in my second equation in front of x is also 3. So if I added these together, I'd get 6x. That doesn't eliminate the x. And we know if I added these, that would not eliminate my y. So what I realize I can do is I could subtract equation 2 from equation 1. Now this gets tricky because you have to subtract the entire equation. So let's look at it. There's two different ways to do this. First, I can say 3x minus 3x. That gives me the 0 that I want. So I've eliminated my x. Next, I would say negative 4y minus 2y. So that's negative 4y minus 2y is going to give me negative 6y. And then 2 minus 26 is going to give me negative 24. To solve for y, I divide both sides by negative 6. So y equals positive 4. So I know in my solution that my y coordinate is positive 4. Again, I go back to one of my original equations and I substitute the y value in. So 3x minus 4 times 4 is equal to 2. 3x minus 16 is equal to 2. I'm going to add 16 to both sides. 3x is equal to 18, so x is equal to 6. So my solution is the ordered pair 6, 4. I'm going to show you a different method. It's really the same thing, but it might be easier for you if you think you're going to forget that you're subtracting each time. So if we start with the 3x minus 4y equals 2, and our second equation, 3x plus 2y equals 26. And if I'm going to subtract the entire equation, that's the same thing as multiplying everything in here by negative 1. So I can just rewrite the system and basically distribute that negative sign. So that's a negative 1. Negative 1 times 3x gives me negative 3x. Negative 1 times positive 2y gives me negative 2y. And then negative 1 times positive 26 gives me negative 26. And once I've done that, now I can just add them because these have become the opposite coefficients. We're going to end up with the same thing. Negative 6y equals negative 24. And then we just continue on till we get our solution. So either one of these ways will work just fine. Let's do a few more practice problems. When I look at a system, I look to make sure my x's are lined up, my y's are lined up, and my constants are lined up. Then I check the coefficients. The coefficient of x here is negative 8. The coefficient here is positive 8. That's great. If I add those, I'm going to get 0. So I know I'm going to be eliminating my x. These add to 0. 3 plus negative 9 is going to give me negative 6y. And 12 plus 12 is 24. Don't forget to add these. Don't just write 12 down here. Solve for y. Divide both sides by negative 6. Y equals negative 4. Again, I go back to one of my original equations. Negative 8x plus 3 times negative 4 equals 12. Negative 8x minus 12 is equal to 12. Add 12 to both sides. Negative 8x is equal to 24. Divide both sides by negative 8. X is equal to negative 3. So the ordered pair that is the solution here is x is negative 3 and y is negative 4. All right, let's look at the next problem here. Again, I look to see if my x's line up, my y's line up, my equal sign, and then my constant. The coefficient in front of x is 1. The coefficient in front of x here is negative 2. That doesn't help me. The coefficient in front of y is 6, and the coefficient in front of y is 6. So they're both positive 6. If I add those, I get 12. So that means I need to subtract. So I'm going to rewrite this system after I've distributed the negative sign. So my equation number 1 stays the same, but now I have to distribute my negative sign. So negative 1 times negative 2x is going to give me positive 2x. Negative 1 times positive 6y is going to give me negative 6y. And negative 1 times negative 8 is going to give me positive 8. So now I can add my equations together. X plus 2x gives me 3x. My y's are eliminated. 13 plus 8 gives me 21. Divide both sides by 3. X equals 7. So I know my x value in my solution is 7. I'm going to go back to one of my original equations. Plug in 7 for x plus 6y equals 13. Subtract 7 from both sides. I've got 6y equals 6. Divide both sides by 6. Y equals 1. So I come back up to my solution. My y coordinate is 1. So the solution to this system is 7, 1. Now, sometimes you get two equations, but they're not in standard form. And remember, standard form is ax plus by equals c. So my equation 1 is in standard form. I've got the x, I've got the y, the equal sign, and the constant. Equation 2 is not. It's in slope-intercept form, which is great when we're graphing, but it doesn't help us when we're solving using elimination. So what I need to do is move my x over to the other side. So I'm going to subtract 6x from both sides, which will give me negative 6x plus y equals negative 32. So now I'm in standard form. I'm going to bring down the other equation that didn't need to be changed and put it right below it. And I notice that I can eliminate my x. Negative 6 plus 6 is going to zero out for me. So 1y plus 7 more y's is 8y. Negative 32 plus 16 is going to give me negative 16. Divide both sides by 8, so y equals negative 2. So I know the y value in my solution is negative 2. I'm going to take that and plug it back into one of my original equations. So I'll start with equation 1. So 6x plus 7 times negative 2 is equal to 16. 6x, 7 times negative 2 is negative 14, is equal to 16. Add 14 to both sides. 6x is equal to 30. Divide both sides by 6. X is equal to 5. So I go back up here, and the solution is 5, negative 2. We have a few more practice. We might come back to those. But let's just take a look at these. This is in standard form. X, y, equal sign constant. This is not in standard form. So I need to change my equation 2 and put it in standard form. I'm going to subtract x from both sides, and remember the x has to come first. So that becomes negative x plus 5y is equal to 10. Bring down my original equation 1, 4x minus 5y equals 5. I notice 5, negative 5, I can eliminate my y's. I'm going to add my two equations. Negative x plus 4x gives me 3x. These are eliminated. 10 plus 5 gives me 15. Divide both sides by 3. X is equal to 5. So my x coordinate is 5. take one of my original equations, plug in 5 for x, 20 minus 5y equals 5, subtract 20 from both sides. I've got negative 5y is equal to negative 15. Divide both sides by negative 5. So y is equal to 3. So if you ever wonder if you have the right solution, you can always plug it back into the other equation to make sure it works. So let's try that in this case just to make sure we have the right solution. So my ordered pair says 5, 3. So 5 times 3 is equal to 5 plus 10. So 15 is equal to 15. So we do have the correct ordered pair. All right, so we're going to move on to the other way to use elimination. Now you notice when we use subtraction, one of the easier ways to use subtraction was to distribute the negative 1 and then use addition. Sometimes when we have a problem, we can't eliminate one of the variables right away. There's a 3 coefficient for the x, an 8 coefficient. Those don't add or subtract to 0. I have a negative 3 in front of the y here and a positive 6. Those don't add or subtract to 0. But I do notice that 3 and 6 have something in common. 6 is a multiple of 3. If I multiply 3 by 2, I would end up with 6. So I need to multiply this by 2 so that I can get this to be negative 6. So that means I have to multiply my entire equation by 2. That's hard to see. So I'm going to do that. I'm going to say 2 times 3x gives me 6x. 2 times negative 3y gives me negative 6y. And 2 times 21 gives me 42. Now you'll notice I'm using equation 2, and I'm using my new rewritten version of equation 1. And now I can eliminate my y's just by adding the two equations together. So in this case, 8x plus 6x gives me 14x. My y's are eliminated, and negative 14 plus 42 gives me 28. Divide both sides by 14. X equals 2. So 2 is my x coordinate. Now we need to go back to one of the original equations. Don't go back to one of the equations that you multiplied. Always go back to an original equation, just in case you made a mistake in your multiplication. So let's put in 2 for x. 3 times 2 minus 3y equals 21. 6 minus 3y equals 21. Subtract 6 from both sides. Negative 3y equals 15. Divide both sides by 3. A negative 3. So y equals negative 5. So the solution to this system is 2, negative 5. All right, here's another example. Coefficients are not the same, they're not the opposites. Coefficients are not the same, they're not the opposites. So I could do one of two things. I could try and make the coefficient in front of the x negative 3 by multiplying this whole equation by negative 3. Or I could eliminate the y by making this a 7. So because I don't want to multiply by a negative if I don't have to, I'm going to multiply the first equation by 7. 7x. I'm going to rewrite my first equation as 7x, 7 times y, plus 7y, and 7 times 4 is 28. Now I can just add the equations. So I've got 10x is equal to 38. Okay, so I noticed this is not going to work out nicely, and I looked back in my notes and I realized this was supposed to be a 12. That'll make it easier for me. So instead of 38, this becomes 40. All right, that'll work. Divide both sides by 10, so x equals 4. I know the x coordinate. Next, I take my 4, plug it back into one of my original equations. So 4 plus y equals 4. Subtract 4 from both sides, y equals 0. And that's okay if y equals 0. We can plug these back in to make sure that works. 4 plus 0 equals 4. 12 minus 0 equals 12. So yes, our solution is 4, 0. Let's look at one more example. X plus y equals 3. Negative 2x plus 4y equals 6. Again, I can't add or subtract here. I can't add or subtract here. This is already a negative, so I think I'll multiply the first equation by 2 and eliminate my x's. So that'll become 2x plus 2y is equal to 6. Let's add these together. My x's are eliminated. 4y plus 2y gives us 6y is equal to 12. So y is equal to 2. So I know the y coordinate in my solution. Go back to one of my original equations. X plus 2 equals 3. Subtract 2 from both sides. X equals 1. So my solution to this system is 1, 2. All right, let's just do this one. Again, I can't add or subtract the coefficients from my x's to zero out, and I can't from my y's. But I see that this is 3, so I could easily make the coefficient in front of my y 3. But even if it's 3, I still can't add them to 0, so I need to make this a negative 3, which means I need to multiply my first equation by negative 3. So negative 3 times 4x gives me negative 12x. Negative 3 times y is negative 3y, and negative 3 times negative 8 gives me positive 24. So now I add my equations. 3x plus a negative 12x is the same as 3x minus 12x. That's negative 9x. 3 plus my y 0 out. 3 plus 24 is 27. Divide both sides by negative 9. X is equal to negative 3. Negative 3 for my x coordinate. Let's go back to an original equation, not the one that I created. 4 times negative 3 plus y equals negative 8. Negative 12 plus y equals negative 8. I'm going to add 12 to both sides, so y equals 4. So the solution is 3, 4. So tomorrow we will practice doing some of these problems in class. Make sure that you followed along with the video and did this on notebook paper. I do expect you to turn this in tomorrow having done all of these problems. See you tomorrow.